Hello, it's Dr. Eaglin, your professor for engineering economics, back for Module 9. I'm going to do this in two parts, so it'll be a lecture 1 and a lecture 2, as we talk about annual equivalent worth. And you're going to first go, why? Why are we talking about annual equivalent worth, annual equivalent analysis? Because in Module 8 and in Module 7, we looked at present worth. We said, hey, you got projects, get the values to present worth, and from present worth, all you got to do is do a comparison, see if the thing actually is positive, and you can make a good decision based on projects. You can do projects versus no project or projects compared to each other and just say, hey, which has the higher number? Now, we're looking at this another way with annual equivalent worth. So what do you actually do here? Well, it really is kind of the same. The annual equivalent is equal to the present worth, and then you just multiply by the factor, discount factor, A over P, IN, which you know that. I mean, you actually know how to do that. That's back there with the good old time value of money equations. So why? Well, we're going to talk about why in just a minute, but the reality is that if the present worth was positive, annualizing it's going to still be positive. It's still going to look like a good project. Well, what are we really doing here? Okay, so let's say we got this little project in our blue up here that's got money out, money out, money in, money in. You take that, you actually get a present worth of it. In this case, that 15% would pretty much look like the MAR. And then you take that whole thing and then you annualize it. But isn't this the green and this the yellow? The same thing, just in different terms? I mean, it is an equivalent money. It is equivalent. Why? Well, most of the time when you're talking about money, you're talking about money year after year, year after year. You're looking at an annual amount of money that you make. Reports are done annually, and it's just the way people like to see the information given. Because we do budgeting on an annual cycle. And if we know what the thing is costing us on an annual basis, it fits nicely into our budgets. Present worth doesn't do that. So that is why we're doing this. We're annualizing the whole thing. Now, when you're looking at this, when you're only talking about costs, we use annual equivalent cost. Okay? We might have revenues, but the revenues have to cover all the costs. So you've got operating costs and capital costs. It's not any different from what we did before. You take the costs, okay, put them in the concept of the present worth. But now we're actually taking that and we're now making it an annual. Okay? So how do we put this together? Well, you're going to actually do some examples here that actually help it make a little bit more sense. One of the calculations that you do in annualized equivalent worth is basically what we call capital costs, or typically that would be called ownership costs. So you buy something, you operate it for a period of time, and then you sell it. Okay? That's actually pretty straightforward calculation here. You have an initial cost, you have a salvage cost. We're going to talk about something that near to your heart that follows this model. So the calculation, the CR, we use the abbreviation CR, and CR of I because it's dependent upon the interest rate, is the initial, that's the big I right here, and the salvage, S, and then all you do is you annualize the present worth of those plus IS. Okay? And that's how you get basically that capital cost associated with it. what kind of items might follow this model where you can say, well, what is the capital ownership cost? What does this cost out on an annualized basis? Well, cars. We buy cars, okay? And after a period of time, we will either trade them in for some sort of value, still has a net salvage value, or we will sell those. So a typical calculation of this, okay, and this is part of your annualized equivalent, but part of the calculation of this is, say we've got a car, in this case, a Mini Cooper, purchased for $19,800, 3 years, sold for $12,078 with an interest rate, in this case, a good interest rate would just be kind of an average interest rate that you would see. A standard car loan interest rate would make perfect sense, so 6%. So your CR, essentially your capital recovery, your cost of ownership, in this case, is $3613.55. That's an annualized cost over 3 years. And looking at, we didn't talk about payments or anything else. Initial price, resale, salvage value. Okay. Some typical cars that we would look at this in. Once you look at the discussion question, I'm going to ask you a little bit about your car. Okay. Now, how do we justify investments with this? Well, let's just take an example. In this case, it doesn't matter if it's a car, doesn't matter if it's not a car. Okay. We have an initial, in this case, of $20,000. We have a salvage value of $4,000 over 5 years at 10%. Now, what is the cost of that? Well, that's the CR. Okay, I minus S. Okay, with the discounting of the P or A over P. And that's a straightforward calculation. You should be able to do that one. Remember, annualizing the thing. Plus IS. And if you calculate this out, you're going to get 4,620.76 with those numbers. Just plug those numbers in. You should get that. I would expect to do that. Now, what I did say was that you have a revenue of $4,400 on this investment. However, you have an annualized equivalent cost, a CR, of $4,620. That's more than $4,400. In fact, it's $220.76 short of the revenue. So, is this a good investment? Well, not unless you're getting another $220.76, because that CR is greater than your revenue. So that would be, and that's as far as I'm going to go with this one lecture, because I'm going to drive home this point. We're taking that concept of the present worth, and you can actually take this, take the 20,000 and the 4,000, move them down to a present worth, and then calculate back across. That's actually what you did there. But in this situation, okay, where you've actually calculated this CR at 10%, you see that it's not. Now, what variables might come into play? There was one assumed variable for this, which was the interest rate, the 10%. Maybe this might be a better investment at a lower interest rate, but you're going to do some calculations with this, and we're going to continue on in lecture 2. I wanted to stop here because this is very tied into the discussion that you're going to have, where I'm going to ask you to look at your car and calculate. And when you're looking at an annualized cost, when you look at that annualized equivalent worth of that car, that's what that car is costing you in real terms as an investment on an annual basis. And now you can look at, are you getting that value out of it? And because that's what I want you to think in terms of value. Anyway, that's it. Hope you enjoyed this was a nice short one. There'll be another nice short one coming up for the second part of this module 9. It's kind of an interesting way. By the way, this is typically how you're going to look at these. So if you can calculate a present worth for a comparison basis, you can easily also calculate annualized equivalence. It's not that much more difficult because of the fact that it just simply isn't. I mean, you know how to do these calcs. Thank you.